this way. I want it to land back to the left of itself. So to make that happen, I'm just going to flip the card over to see where A goes. And A lands right about at this intersection. And where is that intersection at? What is that? -1 to -4, +2. The B, lining it up, putting the card to its basically the left side. Now I just flip the card over to make it rotate down here. Right here. That's at -3, -2. Seeing the pattern?
Yes.
And then C is our last one.
Paul's got it.
Paul's got it? Got it, Paul? Or is he throwing you under the bus?
Oh, I got it.
Oh, you got it. Okay, flip that over. Line that up with C. It's right over here. That's at 5, 1. Okay. Okay, what's our pattern, Paul? Where are we getting this new X value from?
Flip it and Y negative.
Okay, opposite of the Y. And the X you said is staying the same.
Yep.
There you go. So on both rotations, the X and Y flipped. On the clockwise, the X changed to the opposite. On the counterclockwise, the Y changed to the opposite. So use the pattern on the last two here. Where is D going to land? 4 and
1.
-1. And E? 99 and 22. Any questions on that one? Oh, how about the triangles? Did they stay the same or switch? Stayed the same. Well, I should draw it in. Congruent in both cases there. 3 was not congruent. Big old bar to it. Not congruent on the dilation. Got bigger. Got it up there. So not congruent on dilation, congruent on both rotations. And our last one is a 180-degree rotation about the origin. Why did I not tell you whether to go clockwise or counterclockwise?
180 degrees either way.
Either way, you're doomed. I don't think we're doomed. What's 180? If I spin my pen 180 degrees clockwise, which way is it going to, where's it going to point?
Down.
Right at me. If I go 180 degrees counterclockwise,
Down.
it lands in the same spot. If you're going to turn 180 degrees, just turn around backwards. It doesn't matter whether I go to the right or to the left. I'm the same thing. So, here we go. Let's center the axes again. -3, 1, 2, okay, this time we want to go 180 degrees around the origin. How hard is this to do with the card?
Very.
Not very. Just use one of your edges as a 180 degree angle. So line it up on the origin. I'll let this be my origin. O for origin. I'll mark A. new A. Put a little 1 by it. I'd like to see both of those on the other side. Origin, A. So what do I have to do to rotate this thing 180?
Flip it.
Just flip it right over, keep my origin at the origin, line it up with the A, and now I can see where the A is going to land. It's going to land right here, because I can make a straight line.
3, -1.
That's at 3, -1. Think you got a pattern already?
-2, +4.
Let's see. B. Origin to B. Getting a lot of lines here. Here's B. I want to see it on the other side. So I had origin to B. I'm going to flip it over. Like B's going right here.
-2, +4.
-2, +4. 0, 3, that's like my pen. Where's that going to land?
-3.
0, -3. What's the pattern?
Make it -1.
Yeah, keep them in the same order, but take the opposite of both of them. -x, -y. Sophie, you got this?
Yeah.
You liking this today? What?
She doesn't like it with it.
Yeah, she's difficult today. Where's E?
1, 4.
-15. Oh, D I'm on. Or E I'm on, sorry.
15.
Okay. Alright. Summarize on everything we just did in the table. And I will let you have this table on the test so you won't have to copy the whole stinking thing down.
That's -1. For D, was it -1, -4, or is that just?
It started out -1, -4, yes. Those are supposed to be there.
What's the difference?
Now they're both positive.
It looks like it's negative, but it's above.
So. How about, do they stay congruent? The two triangles?
Yes.
Yes. Congruent. Alright. Summarize everything we just found in this nice little table. We're going to name the transformation. This should say transformation summary, not translation. And then we're going to look at the what's called a mapping description. A mapping description. And we just did the little shortcuts that we wrote down are the mapping description. Okay, the first transformation we had was a translation. That takes each ordered pair, x, y. They use a little arrow to say that it moves it or it maps it onto, what was our shortcut for translation? What did we do with the movement? What was it? X plus H, Y plus V. That one's easy to remember. Common sense. If I move left and right, I add that to the X, or subtract if I'm going in negative direction. Vertical, up and down, I subtract it off of the Y or add it to the Y. That makes sense. Reflection. We did two reflections. Reflect over, what did we do first? Y-axis? Not that it matters. We flip over the y-axis, we're actually changing its horizontal position. The height doesn't change. So the mapping If you think about the height staying the same, what happened to the x? That went to its opposite. Then we reflected over the x-axis. That was a vertical change. So the mapping would take each ordered pair. The vertical part changed, the left and right did not. So x stayed the same,
Negative y.
negative y. Then we did the rotations. I think the rotations are the hardest ones to remember. So rotate,
Dilation.
oh, I forgot, oh, I got it on the bottom, I forgot it. Rotate 90 degrees clockwise. The two 90 degrees ones, the x and y switched places, and then each one had a different one that changed. So on the 90 degrees clockwise, we switched x and y, and the x went to its opposite. Rotate 90 degrees counterclockwise. Again, the x and y switched, but the y went to its opposite. And then the 180 degrees rotation stayed the same, both their opposite. And then the one I skipped over was dilation. About the origin. And that one was just multiplied by your scale factor. Okay. We didn't get far enough for me to give you any homework, unfortunately. So we are done for the day. You guys got done, you're about 5 minutes ahead of first hour. They had like 5 minutes left, you guys have 10. So take that in. Tomorrow we have more notes, and then you'll get some problems to do.